moving right along here. We are in homework 4 in statics. This is problem number 3. And we have cables that are attached from 2 stanchions are attached to a single point on a U-Hart building. The cable between A and B is 550 newtons, and the cable between points A and C is 770 newtons, and the dimensions are XOB. This guy right here is 3 meters. YOB is 1.25 meters. XOC, that's this distance right there, is 2 meters. And, oh, wait, did I mess something up here? I said YOC. Okay, no, I'm okay right there. Is, yes, YOC is, there's extra commas in there somewhere. Yeah, right there. 2.5. And ZOC, this guy right here, is 3.5. And then YOA is 5 right here. So we want to find the resultant of the forces acting on the point and the values of the theta x, theta y, and theta z, defining the direction of the force vector. Okay, so let us go and finish this assignment up. Woohoo! So we start out. This is page 3. And I could probably get all this and make it a shorter video, wouldn't I? Homework 4. Yeah. I've written the wrong course number several times before. Okay, wow. That really is annoying. I hope I haven't watched through the videos a bunch of times, but I hope you don't have. Why? There you go. All right. I hope there's not too many instances where this happens that way. Let's see. This is a little bit of a tricky one to draw, isn't it? I guess they're all a little tricky. Right there. Okay, and so let's get this dimension right there. Whoops, it wasn't parallel to there. Well, anyway, we'll also draw this right here. Yeah. And this also has another parallel line over there. I guess I'll make that go downwards. All right. So there you go. There's a line. It's going to connect right up there at A. That's going to be A. Let's see. We'll draw this one over here. It's kind of, these guys are kind of getting in the way of each other a little bit. So that connects to there, to there. That connects to there, to there. This is C. This is B. Let's see. Try to get that parallel right in there. Right, X, Z, and this is Y. And did I not give? I didn't give a dimension. Shoot. I left out that dimension right there. Man, nobody's asked me yet. I'm going to send an email really quick. Let me send an email so I don't forget. Okay, so I fixed that and sent out an email. Concerned I haven't heard from anybody yet asking about that and asking me other questions. So anyway, here it is right here where I have put in that ZOA right there of 0.75 meters. So continuing on here. Kaboom. All right, so where were we? Yes. Drawing these things in here. Here's my ZOA that I just put in there. Here's my YOA. I guess this is my XOB. Here's my YOB. Right into there. This distance right there, I guess that's the leader. Here's my ZOC in there. Here's my XOC, and here is my YOC. I think I've dimensioned everything there. And given, we said that the force between A and C, so A and B, so this is the force AB, is 550 newtons. The force in AC, the absolute value is 770 newtons. And then we have these dimensions, a lot of them. OB is equal to 3 meters. YOB 1.25 meters. All right, and then I guess we'll go XOC is 2 meters in that direction. YOC is 2.5 meters, so that's the height of that. And then the ZOC is 3.5 meters. Okay, 3.5 meters. Okay, doesn't look that way. Well, I guess maybe on my original drawing it does. Okay, and then right here we just said that the YOA, which is usually what we write on first, right? It's 5 meters, so that's up higher than all of them. And then ZOA is 0.75 meters. And now the find A, we want to find the resultant. On A. And then B, we want to find theta x. Whoops, I'm in a Q. For the resultant. Okay, so I try not to make these too long and give too much have you spend too much time, but there's a certain amount of repetition I think that's necessary and good. And by the time you get done doing all three of these problems, you should be able to get these down pretty quickly, hopefully. That is, if you didn't get too frustrated by it. All right, so let's start out with the cable AB. So cable AB. The distance AB in the x direction is going to be that's going to be going to B from A. So this is the second spot, right? So we start here, we finish right here, and so in the x direction it's XOB, right? So and it's in the positive XOB. So where'd you go, OB? There you go, 3 meters. And then the distance AB in the y direction, right? So we're going to end up. Okay, yeah, okay, yeah, it's fine. In the y direction, we end up at YOB 1.25, but we start out, right? So that's going to be 1.25. And we subtract out, that's the destination, so that would be like y2. And then when y1 is going to be at at 5 meters, right there, right? So I can't do that in my head. 1.25 minus, that's going to be negative 3.75 meters, right? And I think I'm going to be messing myself up here. No, I'm just going to write it down. That we start out at, we finish at 0, but we're starting out here. So we're going in the negative ZOA direction. So that's a negative 0.75 meters, right? That's the one we just have right there. So my wife just sent me a text. I'm not going to reply to her, just not this second. So we have the distance right here, AB, 3 squared plus negative 3.75 squared plus negative 0.75 squared. Of course, we leave out all those negatives inside there if we wanted to. 3.75 squared. We'll make sure we add that. That's weird. That's a lot. Okay, let me see. 3.75 squared. That's 14.06. Okay, yeah, that's 9, and then 0.75, which is not going to be a lot. Take the square root, and we end up with 4.861 meters. So if we had the okay, I will reply because it keeps saying she's going to coals. Coal. I think she means the store coal. The force on AB here is going to be it's 550, right? 550 newtons. So 550 times 3 divided by 4.861 I plus our 550 times negative 3.75 and 4.861 J, and 550 times our negative 0.75. It's really not, that 0.75 is really not going to make much difference in the answer, is it? And these are newtons. So as a answer here, 550 is 4.861 divided, so we get 367.8 I, and 550, 3.75, and 4.861 divided a negative 424.3 J, and 550.75 times, but a 4.861 divided, and we get this should be negative, right? It says negative, and just an 84.86 K. Whoop, that's not a very good looking K. Newtons. All right, so now we go to cable AC. And our distance between A and C in the X direction, we're going to see, we start out, X1 is going to be 0, right? So we're starting here at 0, but we're going to go for OC, right? And OC was 2 meters. So DACY, okay, so we're going to end up at YOC, which is 2.5, but we start out at 5, right? We start out at 5. So subtract out 5, and that's a negative 2.5 meters. I could do that one in my head. Check me out. Okay, and then in the Z direction, I didn't leave myself enough space for this, but if we're going to do it correctly, we would say the destination is going to be in the negative ZOC, the negative 3.5, and we're going to subtract out the original position, which is a positive 0.75, right? So that's adding those together. 3.5, and 0.75. That's right. I did have to use my calculator to get negative 4.25 meters. Okay, so our distance, AC, I'll try to leave a little bit of gap right there, is going to be 2 squared plus negative 2.5 squared plus negative 4.25 squared. Didn't need to make my that long. Alright, is that starting to drift upwards? I think it is. I'm moving it. Why bother having the lines there if you don't use them? That's what they're there for, right? Try to make the thing look all nice and neat. I get 5.321 meters. And now I start coming in for FAC is equal to, let's see, we said it was 770 newtons right there. So 770 and times 2. I'm going to double check. Yep, 2. Divide by 5.321. That's I. And 770 times our negative 2.5 and 5.321 J, and then 770 the negative 4.25 and 5.321 K, and these are newtons. They look like kilonewtons right there because of that K and that newton, but they're not. Just, yeah. So the answer here, 770 2 times, 5.321, 289.4 I. 770 2.5 times 5.321 divided, we get negative 361.8 J, and 770 4.25, that's negative, you gotta remember that, and 5.321 divided, so we should get a negative 615 K, right? And now we want to get the resultant at A. It's going to be FAB plus FAC. And let's see if we left ourselves enough room here. The A 367.8 plus 289.4 I plus negative 424.3 plus negative 361.8 J, and then lastly right up here negative 84.86 plus a negative 615.0 K. The K is looking kind of ugly. So our reaction at A, I'll write this one out just to write it once. 367.8 289.4 plus, and those are both positive, right? I just don't want to double triple check that. Yes. And does that make sense? Yes. And they're both going in a positive direction. Okay. So that's 657.2 I, and then plus 423.4.3, yeah, and 361.8, and make sure that that's negative. So we have 786.1 J And I got a suspicion. Is this one both this negative? Negative and negative. Yes, okay. So they're both going in the, this is starting out over here, so they're both going in the negative direction, so it makes sense that these are negative and negative together. Given it a sanity check, even if you're not completely sane. And that's a negative 699.9. That was just a coincidence that came out to that amount. What? Man. Getting lazy, getting tired, people wishing one of my friends a happy birthday and texting me over and over again. It's nice to have friends. All right, so I'm going to call this the answer for this one. I used to tell people I wanted 3 sig figs all the time. And then I said switch 3 to 4. 4 is like the minimum you want to use for like any kind of for most calculations. Sometimes you want to use more than that, but there's actually a caveat. Like if the first digit is 1, then you should use 4 sig figs. If it's the first digit is something other than 1, you could use 3 sig figs and you'll be fine and when reporting an answer. But I just said, you know what, that's just complicated. Let's just say 3 to 4 sig figs and be done with it. Fine. All right, so for this, the last part right here, I'm going to squeeze this in here. Don't be like me, kids. We're going to take these D over D, right? So we want to take... Oh, no, we need the resultant over here. I know. This is why we did it. We're not going to have enough room. I'm going to have to switch to a new page. Oops. I like having the answers next to each other most of the time. We'll go ahead and use the rest of this page right here, I guess. We want to take and find the magnitude here. This is the reason why I assigned this problem now, I remember. So I want you to have experience doing the various, several different varieties of the same thing. Okay, so actually in my, one of the beautiful things of the Hewlett-Packard is it has this thing called a stack, and there's actually 4 layers of this you don't see, and they roll through here. So what you could do is just go square that, flip it around, square that, add it, and now that next one dropped down. We'll flip that around, square it, add it here, square root. Now that didn't make a whole lot of sense to you, I know, but it's just like little games that you could play that you can like do shortcuts, and when you get faster, anyway, you don't care. 1,241 newtons is the total magnitude of that resultant, right? So now we need to write up, this is page 4, and why stop now being thorough? This is problem 3 continued, and what we want to do is get the theta x is going to be the inverse cosine, I'll write it out, of Rx over R, right? Or RAX, maybe. Right, you get the idea. Inverse cosine of 657.2 divided by 1,241. So it actually happens to be in my stack still here, but I don't think any others will be now. So that comes out to 58.02 degrees. Theta x, theta y is going to be the inverse cosine, I guess I'll keep writing it out, RAY over RA. That's not absolute value, this just means the magnitude, by the way. That's what I mean. That's why I'm using it here. I'm going to go ahead and keep these as negative. That's going to give me the And I think it's the technically correct solution there. 1,241. So I go 786.1, make it negative 1241 divided, and so I get 129.3 degrees. And then my last one, theta z, the inverse cosine of RA z over RA inverse cosine of negative 699.9 over 1. And so 699.9 divided inverse cosine, we get 124.3 degrees. So the answer to part B is theta x is equal to 58.02 degrees, theta y is equal to 129.3 degrees, and theta z is going to be 124.3 degrees. Voila! And I probably made some numerical mistakes along the way, but hopefully this video will help anyone who didn't understand what they were supposed to do so that you can correct it for next time. Thank you.